Hello everyone, welcome back to my channel. Today I'll be solving one problem on linked list from LeetCode. So before jumping to the problem description, let me tell you that if you see here, this is an easy problem. And this kind of problem you typically get in an interview when you are left with 5 to 10 minutes. Okay, so the idea here is to understand that you might get this kind of tricky question in your interview and you should be prepared for this. The more you practice, you will be able to get it right in your interview in a very short time. So here it is given, write a function to delete a node in a singly linked list. You will not be given the access to the head of the list. Instead, you will be given the access to the node to be deleted directly. It is guaranteed that the code to be deleted is not a tail node in the list. So let's try to understand this problem description through the example. So let's say you are given this linked list 4519, okay, and in this given linked list, the given node which needs to be deleted is the node with value 5, right? So after deleting 5, your linked list will have 4, 1 and 9, right? So the only trick here is that it's a singly linked list and you are not given the access to the head. That means the only thing you have is the reference to this node which needs to be deleted. Now, as this is a singly linked list, you are not allowed to go to the left side of the given node, right? You can only access the right part of the linked list. So the challenge here is how you can delete this node when you don't have the reference to the head node, right? You cannot start with the beginning of the linked list. So one more example. So here, let's say you are given 4519 and 1 is the node which needs to be deleted. Then after that, you will have 459, right? So I hope this is clear. Let's check the constraint. So constraint are basically things which you need to keep in mind while coding it out. So the constraints here are the number of the nodes in the given list is in range 2 to 1000 and the value will lie between -1000 to 1000 and the value of each node in the list is unique, okay, and then the node to be deleted in the list is not a tail node. So here if you see, these constraints are very straightforward. Now what we need to focus is we simply need to understand how we can remove this given node, right? So let's try to understand the solution for this. So let's try to understand the solution to this problem through a presentation. So let's say you're given this linked list with value 2, 4, 6, 8, okay? And the given node to be deleted is the node with value 4, right? So we want to delete this node. And the only thing we have is we have the access to this node, right? We do not have access to the head node. So in order to delete the node with value 4, ideally we should be deleting this node and the link of the first node should be pointing to the node with value 6, right? So this is something we want to achieve, right? So what could be the possible ways to do it? So the first thing we need to understand is that this is a singly linked list, right? And we cannot have access to the previous nodes. So in the usual way where we generally have the access to the head node, what we used to do is we simply used to traverse the linked list, we search for the node needs to be deleted and we simply change the link of the previous node to point to the next node of the node which needs to be deleted, right? But here we cannot do that. So for this problem, what we can simply do is we can simply copy the value of this node to this node. That means as we have access to this node, we can simply get access to this node, right? And we can copy this value here. And then after copying this, what we can do is we can simply change this link to start pointing to the node with value 8, right? How we can do that? As we already have access to this node, we can also get access to this and we can take the link of this node and assign it here, right? So this will start pointing to the node with value 8, right? So now when you traverse this linked list, you will have 2, 6, 8, which is what we wanted, right? So here if you notice, actually we have not deleted the node. We have simply changed the value and the link of this node, right? And if you see, this will become redundant, right? So this is of no use now. Now if you traverse your linked list, this is 2, 6 and 8, which is your expected output, right? So this is one of the tricky problems you can get in an interview. So now you must be thinking how you can think of such solutions, right? So the idea here is that you can get such intuitions in an interview only when you have a good hands-on practice on this topic. So for example, for now, it is a linked list, right? If you have done enough practice on different problems of linked list, you will simply get this intuition in an interview. So this is not tough, but this is tricky, right? So now we'll see the code for this, okay? So I'll go to the LeetCode website. So here if you see, we have this ID integrated with this website. So what we can do is we can simply select your any of the language and you can code the solution. So here if you see, this is your structure of the list node and this is the function which we need to modify. And here what you will be getting, you will be getting the access to the node which needs to be deleted. So the first thing we need to do here is we need to simply change the value of the node which needs to be deleted, right? So as I mentioned here that this node needs to be deleted, right? The first thing we did is we copy the value of next node to the node to be deleted, right? So what we can do is we can simply write node.val equal to node.next.val, right? So what we are doing, we are simply copying the value of next node to the node which is given to you, right? And similarly, after doing this, you will have a node with value 6. Now the next thing we did is we simply change the pointer to the next node, right? So all you need to do is node.next equal to node.next.next. So now what we are doing, we are simply changing the link of the given node. So here for this node, the link will get changed to this node. That means we are simply using the link of this node and we are assigning it here. If you see node.next equal to node.next.next, right? So let's run this program. So I'll run this code here. So if you see, this got accepted. Your input was 4519 and the node to be deleted is 5. And here the output we got is 419. So let me submit this problem. So here if you see, the solution got accepted. Okay. So now the next thing to notice is what is the time complexity and the space complexity for this problem. So if you see, we are simply performing 2 instructions, right? That means the time complexity here would be order of 1. And also the space complexity would be order of 1 because we are not using any extra space. So I hope the problem is clear to you. I found this problem interesting, so I made a video on this. That's it about this video. If you like this video, please hit the like button and also let me know your thoughts on this kind of problem given in an interview. Also, you can share your experience if you have received this kind of problem in an interview. So yeah, that's it for now. And also, if you're new to this channel and interested in competitive programming, don't forget to hit the subscribe button because I'm going to upload more such videos which will help you to crack your coding interviews. Thank you for watching.